Hey guys, Mrs. O'Donnell here. Today we are solving quadratic equations with square roots. Our goal is to solve simple quadratic equations using square roots. Again, if you find you're having any trouble, any questions, pop into my office hours. Download that Google Meet app to your phone. You can go sit outside in the grass and chat with me via office hours in the grass, or eat your breakfast with me and my kids. All right, so our warm-up here is to identify the mistake. You could go ahead and pause the video and give this problem a try. For those of you who haven't paused the video, or if you're just coming back, let's go ahead and take a look at this together. So it looks like, let's see here, did they find the square root of 32 to be 5, 7? Let's see here. 5 square root of 7, I do not think is the square root of 32. I think that's our first mistake that's happening here. So let's see here, 32 divides by 16. All right, so 32 becomes 16 times 2, and the square root of 16 is 4. So this should have been the number 4. So it should have been negative 4 plus 4 square root of 7 over 8. And then from there, they really can't do much because we don't have square roots, right? We don't have the same label, so we kind of just have to leave it as is. If you really wanted to try simplifying it, you could break it down this way, right, into two individual fractions. Sometimes that's helpful. Or you could even go one step further here. Negative 4/8 is the same thing as negative 1/2. 4 square root of 7 over 8, that's the same as 1 square root of 7 over 2. We could smush it back together here. So this is the same thing as saying negative 1 plus the square root of 7 over 2. That'd probably be the most simplified form. All right, let's take a look at another mistake. Again, if you want, you could go ahead and pause the video here, try it out, and then come on back in another minute or so. All right, so you may be looking at this problem thinking, oh my gosh, Mrs. O'Donnell, there is a cube here. We are not working with cubes. We're in a quadratics unit. While that is true, you guys know how to operate with functions, right? If you have f of some number, right, all that's saying, that direction is telling you, is whatever that number is, so in this case, the square root of 5, you're going to plug it in everywhere you see an x in your function. So we've got the square root of 5 cubed minus 3 times the square root of 5 plus 6. So it looks like they plugged everything in right there. And then let's see here. They did some fancy stuff here. They said, oh, the square root of 5 cubed, that's the square root of 5 times the square root of 5 times the square root of 5, or the square root of 5 squared times the square root of 5. And I know the square root and the square are inverses, so that's 5 square root of 5. All right, so that's how they got that. And then 3 square root of 5, and then plus 6. So far, so good. And then this is where they must have gone wrong. So we've got 5 square root of 5 minus 3 square root of 5, and they got 2 square root of 5 plus 6. So no, that looks good so far. And the last step, 2 square root of 5 plus 6, 8 square root of 5. What did they do? They combined unlike terms, right? They don't have matching labels. The 6 would have to have a square root of 5 attached to it by multiplication for us to be able to add it to this 2 square root of 5. All right, so this stage is actually, this spot right here is where you have to stop at this for this problem. All right, so let's take a look at solving using our square roots. So first of all, we could go ahead and graph to find our solutions, right? This one's a pretty simple one to factor and graph. I could pull a 3 out, and I'm left with x squared minus 4 And I see that that's a difference of two perfect squares. So I have x plus 2, x minus 2. And if I'm just sketching my graph, I'm not being, exactly precise, but I know, okay, x plus 2, that's going to give me a root right there at that -2, and x minus 2 is going to give me a root right there at that +2. I know that I have a positive a value, which means my parabola is going to open up. And I also know that I have this -12 is actually telling me where my y-intercept is going to be. My y-intercept is going to be all the way down here at this -12, and that's also my vertex. So I can go ahead and sketch my graph of this equation, this quadratic. It's hard to do with my little bamboo pad, but there we go, I'm getting it done. All right, so we know that our solutions are going to be -2 and 2. Okay, because those are my x-intercepts. That's what my zero product property is telling me from factored form. But I'm wondering if I could have gotten there faster. So let's check it out, solving it like an equation. Whenever we solve equations, and typically we've solved simple like linear functions, but we did a little bit with exponential functions. Whenever we solve equations, we use SADMAP. Right? Let's see if I can get clicked over onto blue. There we go. We use that inverse order of operations to help us keep track of what we need to undo first. So if I have 3x squared minus 12 equals 0, the first thing I'm going to get rid of or undo is the added or subtracted term from my x. So I see I've got this -12. That's what I'm going to undo first. The opposite or the inverse of -12 would be +12. If I do it to one side of my equal sign, I must do it to the other. So I've got, let's see here, 3x squared. -12 plus 12 makes 0, which is what I wanted. 0 plus 12, that's 12. All right, so far so good. 3x squared plus 0, that leaves me with just 3x squared. Okay, and let's see here. Next, I want to get rid of or undo my multiplied or divided term. So this 3 is being multiplied by my x squared, so I'm going to do the opposite, which is divide. If I do it to one side of my equal sign, I have to keep my equation balanced and do it to the other side as well. So 3 divided by 3, that leaves me with 1x squared. I'm going to come up on over here. And then 12 divided by 3, well, that leaves me with 4. Now this is the spot where it starts to get a little tricky. I want to get rid of my exponent. I want to get rid of that square. So I have to think about what is the opposite or the inverse operation of a square. Well, that's a square root. If I do it to one side of my equal sign, I have to do it to the other. So the square root of x squared, well, that's just x. The square root of 4 is 2. Now this is where it gets a little tricky, right? Because notice we just got one answer, but we know that we should have gotten 2 answers. When you are solving a square, something squared, you have to think about all possible things, all possible numbers that could go into this square that could make that +4. So another possible number that could go in would be this -2. Okay, and what that's called here, when you get this +2, that's called your principal square root. That's your positive square root that you get back without having to do too much any other thinking, right? Here you have to really make sure that you're thinking about that negative root that you could also possibly get back. And voila, there's your solutions. Okay, if you're not so fond of factoring, this is another way to get through some of those simple problems. Before I move on completely from this problem solving using square roots, I want to make sure that you guys remember you can always check your work by plugging back in, right? So we said, hey, our solutions are -2 and +2. Well, you can go back to that original equation, 3x squared minus 12 equals 0, and you can plug your solutions back in to see if they actually work. -2 squared minus 12 equals 0. Make sure when you do that you're going to follow PEMDAS. Please excuse my dear Aunt Sally, or parentheses, exponents, multiplication, division, addition, subtraction. Those order of operations to help you work this out, right? So -2 squared is 4. 3 times 4 is 12. And 12 minus 12 is 0. And 0 is equal to 0, so -2 worked. But it's not good enough to just check one of your solutions. You have to make sure you check them both, right? So 3x squared minus 12 equals 0. I'm going to plug in my +2 this time. And I'll end up with the same thing. 3 times 4 minus 12. And 3 times 4 is 12. 12 minus 12 is 0. 0 equals 0. So +2 worked. So both solutions worked. It's always a good idea to check your work. All right, let's look at some other examples here. So again, solving using square roots. I'm really just following SADMAP. Right? My inverse order of operations, that helps me solve. Okay, so first thing I'm going to get rid of is this added or subtracted term by doing the opposite. So I'm going to add 13 to both sides here. So I've got 4x squared. -13 plus 13 is 0. 15 plus 13 is 28. 4x squared plus 0 is just 4x squared equals 28. I need to get rid of that multiplied term next. So the opposite of multiplying by 4 is dividing by 4. If I do it to one side of my equal sign, I have to do it to both to keep my equation balanced. 4 divided by 4 leaves me with 1x squared. And let's see here, 28 divided by 4, that leaves me with 7. I'm almost done. I have to think about all possible answers that can be plugged into x squared that will give me 7. So I'm going to take the square root of both sides. And this is where 7 doesn't work out so nicely. So we could say it's the plus or minus the square root of 7 would be my final answer. So this is, my final answer would be the positive or the principal square root of 7 and also the negative square root of 7. Okay, let's hop on over and look at another example. Okay, so I've got x minus 1 squared equals 25. Well, again, I'm still following my reverse order of operations. I want to get rid of my added or subtracted term first, but I have these parentheses there. So those parentheses are changing my order of operations. This addition and subtraction this subtraction is actually going to be operated on in the last step with the parentheses. So the first thing I'm going to get rid of is the square. The opposite of a square is a square root. If I do it to one side of my equal sign, I do it to both. So the square root and the square undo each other. Right, they're inverses. So I have x minus 1 equals, and I've got this 25. Well, I have to consider both the positive root of 25, but I also have to consider the negative root of 25. Okay, so I've got my principal root, and then I've got that negative root as well. And now I am going to be solving two equations kind of in tandem. Get rid of that -1 or -1 by doing the opposite, which is +1 to both sides of my equal sign. And I have x plus 0 equals 5 plus 1 is 6. So x equals 6. And then same thing over here. I'm going to add 1 to both sides of my equal sign. -1 plus 1 is 0. -5 plus 1 is -4. X plus 0 is just x, so x equals -4. And of course, you can take both of those answers, go back to that original equation and plug them in to check your work. All right, let's run through this vertex form real quick. Right, so still following my inverse order of operations. Subtract 2. 3 x squared minus 8 equals -12. Divide by 3. X squared minus 8 equals -4. add 8, x squared equals